Lesson 43, Simplifying Rational Expressions. Rational expressions are fractions with a variable in the denominator. And the denominator cannot equal, and we have this big blank right now. What can the denominator not be equal to? Well, whenever we are working with fractions, we never want the denominator to be equal to 0. Holy moly. Okay, we never want the denominator to be equal to 0 because we need to remember that that fraction bar means the same thing to divide, and we can never divide by a 0. We don't know how to divide by 0, so it's undefined. So we don't want the denominator to be equal to 0. It says determine values for which each rational expression is undefined. So, a rational expression will be undefined where the denominator is equal to 0. So, the denominator is always what's on the bottom of that fraction. So, I have that 3x is equal to 0. But I can simplify this further. And to do that, we would divide by 3 on both sides. Holy crap. Divide by 3 on both sides, and that means that the expression is undefined where x is equal to 0. Now we can do the same thing on the next one. I want to set this denominator equal to 0 because that's where it's undefined. So I have that x minus 7 is equal to 0. But I don't want to know the whole denominator is equal to 0. I want to know where it's going to be undefined, which is where x is going to cause the denominator to be 0. So I'm going to add 7 to both sides of that equal sign. And that leaves me with x is equal to 7. Now some of you may be able to look at this and see, well, x is being multiplied by 3 and anything times 0 will give us 0. So it's got to be 0. Or you could look at this one and see, well, I'm subtracting 7, so to get 0, this would have to be a positive 7. Absolutely true. This is how you show your work. On the last one, this would be undefined where, once again, that denominator is equal to 0. So I want you to find the value for x for which the expression is undefined on your own paper, please. Simplify each rational expression, determine undefined values. So, we've been working on factoring a little bit, and for us to simplify these, we're going to have to factor. So, on A, the top, I can factor a number out of both of these. I can't take an x because x isn't in both terms. So, the number that I can factor out of both is a 9. And if I take, and if I take 9 out, 27x divided by 9 will give me 3x plus 9 divided by 9 gives me 1 over x minus 10. So, this is simplified. I can't cancel anything because I don't have anything the same on top and bottom. And it wants us to determine the undefined values. And we can look at this and see it's going to be where x minus 10 is equal to 0. So I'm going to have to add 10 to both sides to get x by itself. So I get that x is 10. On the next one, same thing, I'm going to factor, and on this one I can factor the numerator and the denominator. On example B, I can factor out of the numerator and the denominator. So in the numerator, the number that I can factor out of both is a 4. And I have x squared and x. So I'm going to take the smallest exponent of x, which is just going to be x to the first, or just x. And if I take 8x squared divided by 4x, that will give me 2x minus 4x divided by 4x gives me 1. Over, in the denominator, I can factor out again a 4 and an x. So I have 12x squared divided by 4x leaves me with 3x plus 8x divided by 4x leaves me with 2. So I can cancel 4's and I can cancel x's, which means that my final answer is going to be 2x minus 1 over 3x plus 2. And I'm not going to rewrite it because I'm having a heck of a time with my pen. So the only thing that I have left to do is to find my excluded values. Now, because I have my highest exponent down here is a 2, my degree is a 2, that means I'm going to have 2 values for x for which this is undefined. And, in the first one, I'm going to set this 4x equal to 0. So to get x by itself, we have to divide by 4, which leaves me with x equals 4. So that's my first one. And my other one is where this part is going to be set equal to 0. So I have 3x plus 2 equals 0. So to get x by itself, the first thing I must do is subtract 2 from both sides. Over. And this part cancels. So I have 3x equals negative 2. And to get x by itself, I need to divide by 3 on both sides. So I have that x is also, or that the expression is also undefined at x equals negative 2/3. Okay? Both of this part right here, and each of these are part of your answer. So on C, I would like for you to try that on your own paper. Pause the video and we'll go over it together in just a moment. So on C, I can factor a number out of both of those. I can factor a 2. And I have x squared and x, which means I can factor an x. And on the inside, 2x squared divided by 2x is going to leave me with x, minus 14x divided by 2x is going to leave me with 7. Over. On this one, I can factor out a 4, and I'm left with 4x divided by 4 leaves me with just x, minus 28 divided by 4 leaves me with 7. Now in this case, I can cancel these quantities, okay, and I can only do that if it's the entire quantity and it's being multiplied, okay. If it's just, I don't have a good example right now. If it was 4x minus 7 and x minus 7 on top, I can't cancel that because the 4 is being multiplied by the x, okay? It has to be the whole quantity that's being canceled. I can also reduce the 2 by 2 to a 1 and the 4 by 2 to a 2. So my final answer on this one, the most simplified version, is going to be x over 2. Now that being said, I still have to find where it is going to be undefined, and that is going to be where this x minus 7 is equal to 0. And to get x by itself, we add 7 to both sides. So I'm left with x equals 7. This is my final answer. The distance a car has traveled is equal to 8.1 t plus 0.9 t squared. It took 1.8 t squared seconds to travel that far. What is the velocity of the car in simplest form? So what we're going to do to help us solve this is the same thing that we've been doing all along. We're going to take that 8.1 t, there's supposed to be a 1 there, t plus 0.9 t squared, and I'm going to divide it by 1.8 t squared. So on the top, I can factor a 0.9 out of both. Okay, so if I do that, I have 0.9, and I can also take a t out of both. I'm going to have t out here. When I do that, I'm going to be left with 9. The t came out, so it's over here now, plus 0.9 divided by 0.9 is going to give me 1, and t squared divided by t leaves me with t, over. On the bottom, I just have that 1.8 t squared. So I can reduce these by 0.9 also. So 0.9 goes into 0.9 one time, and 0.9 goes into 1.8 two times. And I also have t to the first here, which I can move down and end up subtracting that 1, which leaves me with a final answer of 9 plus t over 2t. Now this is an example of what I cannot do to cancel. I can't cancel these t's because this t is being added with this 9. Okay, if they were being multiplied, I could cancel it, but it's not. It's being added, so I cannot cancel it. This is my final answer. Lesson 44, finding slope using the slope formula. The best part about today's lesson is that we've already talked about the slope formula in a previous lesson, because I think it's best to just go ahead and give it to you because it's a surefire way to figure out the slope when you're dealing with 2 points. And so today is basically going to be a review and a practice of what you already know. It says slope is a measure of the steepness of a line. The slope m of a line containing points x1, y1, and x2, y2 is, and they give us this nice formula. Alright, fine. Alright. So, the formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is the change in y over the change in x. We've always talked about slope being rise over run, and when you're looking at the coordinate plane, it's exactly rise over run, and now we talk about it as x and y because rise is up and down. Well, up and down, this is my y-axis. I run from left to right, and that's my x-axis. So that's where we get that from. So it wants to determine the slope of the line that contain the given points. So they're giving me, on each of these, they're giving me x sub 1, y sub 1, and x sub 2, y sub 2. Okay? So when we do this, I'm going to use my formula, which I would love to be able to write with my pen. So I'm going to use my formula. M equals y sub 2 minus y sub 1. And it's important that you write these as subscripts and not as exponents because that's something very common that we do. And then some of us get confused and we think we need to square something, and we do not. Okay? This just means the first x and the first y and the second y. That's all that it means. Okay? So please don't be confused by that. So, my y sub 2 is what I'm going to start with. Y sub 2 is 11. And as I plug them in, I'm going to scratch them out. So, y sub 2 is 11. I'm going to put a line through that, and I'm going to plug it in over here. So, instead of y sub 2, I'm going to put 11. Minus, instead of y sub 1, I'm going to put 7. It's very important that you label your points and that you mark them off as you go to eliminate any errors that you may have. X sub 2 is 9, So I'm going to plug in 9 minus x sub 1 is 5. So I put 5. So now all I have to do is the math. 11 minus 7 is 4. 9 minus 5 is 4. So the slope of this line is 1, or 1 over 1. Okay? That's my final answer. I would like for you to try and do B and C on your own paper. So please pause the video and work on those two. Okay. And we're going to do D together. Okay? So again, we're going to start by labeling x sub 1, y sub 1, x sub 2, y sub 2. And it's always x sub 1, y sub 1, x sub 2, y sub... I put 2. Because this is point 1. This is my first point. It doesn't really matter which way you put it, but it is important that x and y are always together and that your x1 goes with your x coordinate, your y1 goes with your y coordinate. And then your x sub 2, y sub 2, that's your other point that we're talking about. So we always have x with x and y with y, but the sub 1 and sub 2 must always be together for the same point. So I'm going to cheat and use the formula that I already have written up here to plug into. You should always rewrite the formula whenever you're doing one of these problems. I will never, ever, ever accept for you to just plug it in without writing the formula. You need to write the formula so you do not make a mistake. So y sub 2 is negative 8. So I'm going to plug that in for y sub 2. Minus y sub 1, which is 2, over x sub 2, which is 2, minus x sub 1, which is negative 3. This is another reason why it's very important to plug into the formula, because we sometimes forget about a negative whenever our coordinate has a negative and there's a negative in the problem. Okay, we have to make sure that we're very careful about that. So on top we have negative 8 minus 2 gives me a negative 10 over. Then I have a double negative, which I hope we all know at this point gives us a positive. So 2 plus 3 is 5, and negative 10 divided by 5 gives me a slope of negative 2, and that's my final answer. Determine the slope of the line that contains the given points. Whenever you do this, we have x and y. We should always know that this is one coordinate, this is another coordinate, and this is another coordinate. Okay? So whenever I have this, I always start by taking the first one and I call this x sub 1, y sub 1, and x sub 2, y sub 2. Okay? So once I'm here, I can find the slope. So that's what I would like for you to do on your own paper. Please pause and find the slope at this time. So our formula is what we should always start with to find the slope of a line, which is always m equals y sub 2 minus, that looks not like a minus sign, but pretend like it does, y sub 1 over x sub 2 minus x sub 1. So, using the points that I chose, you could have chose any 2 points and you could have labeled them any way that you want to. Okay? So, instead of y sub 2, I'm going to put in negative 3 minus y sub 1, which is a positive 3, over x sub 2, which is 1, minus x sub 1, which is negative 2. So whenever I do this, on top I have negative 3 minus 3 gives me a negative 6, and then minus a negative 2 gives me a positive here, so I have 1 plus 2, which gives me 3, and a slope equal, that's an equal sign, to negative 2. Final answer. It says determine the slope of the given line. And they've given us, once again, a graph here. They've given us 2 to work with. And they tell us the coordinates. This point's not supposed to be there, so please ignore it. Okay? So I'm going to say that this is x sub 1, y sub 1, and x sub 2, y sub 2, and I usually always label them from left to right because that's the way that we read a graph, is from left to right. So I just usually start with the first one I see on the left and I label it and then go to the next one. Once again, you could put them in any order, you're still going to get the same answer. So I'm going to write my formula, which is m equals that's a y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So my y sub 2 is 7 minus my y sub 1 is 4 over my x sub 2 is negative 2 minus my x sub 1 is negative 4. So whenever I do this math, I have 7 minus 4, which is 3, over negative 2 minus the negative here gives me a positive. So negative 2 plus 4 is going to give me 2. And this is how I leave my slope. I don't want to have a decimal for slope because slope is always rise over run. So I want to see it in that fraction form. On the others, we did talk about going ahead if it was, say, 4 over 2. We would reduce it to 2 because a 2 is always understood over 1. So we can very quickly get it back to that fraction. But we don't want to have to deal with changing a decimal back to a fraction. So whenever we find slope, we leave it as an improper fraction if it doesn't divide evenly. I would like for you to do B on your own paper at this time. On B, once again, we start by writing our equation. M equals y sub 2 minus y sub 1 over x sub 2, that's a 2, minus x sub 1. So I'm going to label these starting from left to right. I have x sub 1, y sub 1, and x sub 2, y sub 2. So instead of y sub 2, I'm going to plug in this negative 3 minus y sub 1, which is 1, over x sub 2, which is negative 4, minus x sub 1, which is negative 7. So double negatives here is going to give me a positive, something we quickly see. And I have negative 3 minus 1, which is negative 4, over, I have negative 4 plus 7 is going to give me a positive 3. So my final answer, I'm going to write it so you can actually read it, is negative 4 thirds. And once again, I'm going to leave it as that fraction, not going to change it to a mixed number or a decimal. On problems or lines like C and D, these are very special types of slope with our lines here. You can see very quickly that this line is horizontal. And all horizontal lines have the exact same slope. And we're going to figure it out here so that we can remember. We always start by writing our formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm going to label x sub 1, y sub 1, so I know what I'm plugging in, and x sub 2, y sub 2. So instead of y sub 2, I'm going to plug in 4, minus y sub 1, which is also 4, over x sub 2, which is 6, minus x sub 1, which is negative 6. So I have I have 4 minus 4, which is going to give me a 0. And then 6 minus a negative gives me a positive 6. So 6 plus 6 gives me 12. And 0 divided by 12 is 0. Okay? You can see, looking at this horizontal line, it doesn't rise or fall. Okay? It stays the same the whole time. So anytime we see a horizontal line, it is an understood slope of 0. Please, please, please put that in your notes. It's very important that you remember it. It'll save you lots of time. On D, just like a horizontal line, there is one specific slope for all vertical lines. So we'll work that out here together. I have x sub 1, y sub 1, and x sub 2, whoops, that's an x, sub 2, y sub 2. My formula is m equals y sub 1, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So instead of y sub 2, I'm going to plug in my negative 5. So I have negative 5 minus y sub 1, which is 1, over x sub 2, which is 7, minus x sub 1, which is 7. So on top I have negative 5 minus 1 gives me a negative 6, and 7 minus 7 gives me 0. Well, negative 6 divided by 0, it's probably unlikely that you have your calculator in front of you, but if you do, go ahead and plug that in and see what it tells you. Even if you are at home and you have your phone, plug that in and see what it tells you. It should tell you that you get an error, because we don't know how to divide by 0. So vertical lines are all known to have an undefined slope. So the slope of any vertical line is undefined. Alright, so a rate of change is a ratio that compares the change in one quantity with the change in another. So it says a biologist is trying to determine the top speed of a cheetah. The second hand was at 14 seconds when he began timing, and at 51 seconds when the cheetah had run 1,184 meters. What was the speed of the cheetah in meters per second? So, first of all, some things that we need to think about. Meters per second. How would I write that as a fraction? Meters per second. I hope that you're thinking it would be meters per second, because it should be. That means meters are going to be on top. So I'm going to have 2 points, okay? At 14 seconds, how far had the cheetah gone? That's when he said, it says that's when the cheetah the second hand was at 14 seconds when he began timing. Okay, so how far is the cheetah gone? Nowhere, right? So it's at 0 at that point. Then it was at 51 seconds. 51 seconds, and the cheetah had traveled 1,184 meters. Okay, this is my x and my y. You should remember that the change in y over the change in x is my slope, which is what I'm finding here. Okay, that's an equal sign, not a less than sign. So you can see that my meters are my y value, which is how I've written this. I've written this in the form of x and y, right? So this is going to be my x sub 1, y sub 1. This is going to be my x sub 2, y sub 2. And what I would like is for you on your own paper to find the speed of the cheetah in meters per second.